everybody to, as Chris mentioned, the sixth session in the APAC webinar series. As Chris mentioned, the session we'll be going through today is going to be really focusing on how we can lower our costs without sacrificing performance and availability of our existing AWS deployments. This particular session may differ a little from the other sessions in the series you have been attending, where we've actually been going through some really cool technology and really cool ways that we can architect for different use cases and workloads, such as for big data, such as for scalable web applications, and such as for automation and management and operational support for the AWS platform. What we're going to be focusing on today is really taking those various architectures that you might have been taken through and how we can really optimize them for cost, specifically around reducing the monthly spend that you would apply to the AWS platform or your utilization, but also reduce the time and resources that your organization needs to commit to actually manage and support the AWS deployments. So if we dive a little deeper into what we will be covering today, first and foremost, I'll be taking you through some strategies of how you can actually lower your overall AWS bill, where we can actually use certain technologies, certain features, and certain services that will actually have a significant impact in the amount of time, resources, and money that you actually spend on your AWS utilization. At the end of the day, the Amazon Web Services organization really has a retail aspect in its DNA coming from Amazon.com. And as a retail business, we always want to ensure we're offering the best price versus performance to our customers. And one of the benefits that all of our customers can actually inherit is that regardless of size or the utilization of the AWS platform, when we actually have more organizations, more users using the multi-tenant environment, we're actually able to offload a lot of the cost savings that we get from improved operational efficiencies, from improved economies of scale to our user base. And we've actually done this over the history of the Amazon Web Services organization, where we've actually applied significant cost reductions automatically to our user base. And what that actually translates to is the cost per user has actually decreased over time. And the benefit of leveraging a public cloud platform is that a customer actually doesn't need to do anything to inherit those cost savings. Because of the pay-as-you-go model, or the pay-for-what-you-use model, the next hour that cost reduction takes place will actually be inherited or will immediately apply to your actual AWS bill. Of course, when we are actually reducing the overall cost of our utilization of the AWS platform, we want to ensure that we're not sacrificing our performance and we're not sacrificing resiliency. So as I mentioned, I'll actually take you through some strategies how you will not have to sacrifice performance or resiliency just to save time and money on your AWS platform. And what this directly translates to, what is the outcome from this strategy, is that it really allows your organization to spend more time on things that makes your organization agile, innovative, and at the end of the day, more competitive. It actually allows your organization to commit more resources to ensure that you're bringing products, you're bringing solutions to the end user or to your end customers, and not need to focus on the day-to-day operational tasks of the IT infrastructure. And to see how some of those strategies have been applied, I'll actually take you through some of the real-world customers that we've worked with that have actually employed some of these strategies that I'll go through. And at the end of the day, of course, we want to make it very simple for you to use. So one of the strategies I just mentioned is that as an Amazon Web Services user, you can actually do absolutely nothing to inherit certain cost savings. And that will come through the cost reductions that we apply to our various services. But of course, we want to take a more proactive take advantage of those cost reductions and then inherit those cost savings, but we want to actually optimize our environment not only for performance and resiliency, but at the end of the day, we want to optimize our environments for cost. Now, before I get into the actual strategies, I just wanted to take a step back and for the benefit of the audience who are at the start of their cloud journey, take you through really the 6 benefits or the 6 characteristics that we see are the advantages of an organization or a customer leveraging any public cloud computing platform, with of course AWS in this case. So first and foremost, a primary benefit of any public cloud, true public cloud computing platform is the pay-as-you-go model. It's essentially a utility model. So if you think about how you consume and procure utilities such as gas, electricity, and water, procuring and using IT infrastructure follows the same model, where you will actually only be charged when you actually use that particular resource. So only when a particular virtual machine, or in our case an EC2 instance, is up and running, will you actually incur running costs. So if you were to terminate or power off that instance, then you'll actually incur no cost. For things like storage, only when you're actually consuming and using storage to store your actual content will you be incurring costs. And therefore, when you remove that content, you'll actually stop incurring costs for the storage system that you're using because there's actually no storage that you've been consuming. And for things like storage, it's special cases where you get advantages of not needing to actually provision an upfront amount of storage or provision an upfront amount of capacity to store your data. You actually only pay for the storage as you consume it. And of course, we want to ensure that the public cloud platform brings you a low ongoing cost. And like I mentioned before, customers can leverage our economies of scale. In other words, as we procure more customers or acquire more customers, all of our customers of the platform, whether big or small, can actually take advantage of the operational efficiency improvements as well as the cost reductions we incur as a result directly of economies of scale. So in a multi-tenant environment like a public cloud platform, as the platform gets larger and larger in terms of utilization, all customers will benefit with low ongoing costs. Of course, another benefit of a public cloud platform is the ability to actually scale up and also, just as important, scale down your resources that you're using to actually meet the real-world demands of your user base. So no longer do you actually have to provision your resources and your IT infrastructure to cope with your predicted peak workloads for the platform. For things like internet-facing applications, whether it might be your e-commerce site, whether it might be your web application, maybe it's your mobile application, it could even be your IoT platform, you don't actually have to try and guess. You don't have to try and guess what the demand or what the capacity requirements are for your actual IT infrastructure. The IT infrastructure will be able to grow and shrink as demand increases and demand subsides. Any public cloud computing platform will also provide the ability for your organization to be very agile and very innovative. And it achieves this by actually removing the barrier of IT infrastructure, especially in terms of provisioning times. So by leveraging a public cloud platform, your entire organization, whether it's your actual end business users, whether it's your developers, whether it's your IT teams, whether it's your other entities within the organization, are able to actually spin up and spin down infrastructure in a matter of minutes rather than the normal or traditional way of procuring infrastructure, which can take weeks, if not months. The fifth benefit of a public cloud platform is that organizations can now focus on the business. AWS has actually removed a lot of that undifferentiated heavy lifting requirements for supporting IT infrastructure. AWS will now be responsible for all the bricks and mortar that goes into supporting the data centers to host the various network equipment, storage equipment, and server hardware. AWS will be responsible for maintaining and ensuring that the actual hardware and physical equipment lights are on and remain on. AWS will ensure that all the security compliance and controls are in place all the way to the actual operating system. So the customers can actually focus on their actual applications and bring in innovation to the application workloads. And then finally, any true public cloud computing environment will always allow you to have global reach. So it allows those customers and the users to actually provision and deploy their applications to support a globally distributed set of user base. So we live in an internet age when we're no longer restricted by country borders. And a public cloud platform will allow you to take advantage of that, where you can actually deploy your application environments or your application workloads across multiple regions or multiple locations across the globe to address the business requirements. Whereas if it's certain users in a particular location outside of your organization's country area, or whether it's supporting a globally distributed set of users accessing your web application. For the purposes of today's session, though, we'll focus on those first three benefits. We want to focus on how to reduce our costs and our utilization of the AWS platform. Now, before I get into the actual strategy, I wanted to just highlight that we're making a couple of assumptions here. So for all of you who are attending, we're actually assuming that you already use AWS. You may have used the AWS in a very basic fashion in terms of maybe spinning up some EC2 instances for your virtual machine or server environments. You might have used things like S3 to actually store certain content. You might have provisioned up a relational database service or RDS to have a managed relational database running your favorite database engine for your application. We also assume that you like it, of course. And so what we're going to focus on is that, yes, you are using it, yes, you like it, but the actual monthly bill that you are getting isn't actually projected or isn't meeting your original projections of the actual costs allocated or costs projected for leveraging the AWS platform. So maybe you're actually spending more than you planned. Or maybe you are happy with what you're spending, but there's always ways where we can look at spending less. So in other words, we're actually taking the model or the mindset of public cloud platforms where you pay for what you use and actually changing that to paying for what you need. So at any given time, the actual IT resources that you have provisioned is actually meeting and adapting to the business requirements at that specific time. Any idle or unutilized resources are automatically removed or decommissioned or terminated from the AWS platform. And we'll talk about some of the strategies of how we can do that. So what should you do? So first and foremost, the first recommendation is that we want to limit your resource provisioning. And what we mean by that is we want to limit which users have the capability to leverage AWS resources and deploy and manage those AWS resources. If you were to simply allocate administrative access or total access to a wide range of users, you'll quickly find that your AWS spend will spiral out of control because those users will simply be provisioning up various resources and more than likely will be forgetting to actually turn down or spin down those resources. And so by limiting resource provisioning to only a certain select group to actually control and perform certain tasks, we're actually reducing the surface area for the potential of resources to be spiraling out of control. And so what we can actually do, for example, is allocate certain rules, permissions, and policies against users that might need only read access to the system. And so this could include users from your legal department. It could be users from your compliance and auditing department, which only simply need to see a view of the actual AWS resources being used, but they don't need to change or provision anything. And then you might have certain users who need to perform things like backups. And so rather than giving them total access to the AWS environment where they can maybe fire up certain services that aren't part of their normal day-to-day role and responsibility, you can actually give them access to only access our storage services like S3. Or maybe you want to allocate permissions and policies to only developers where they can provision resources at their, based on only to a non-production environment. So developers aren't able to quickly spin up resources in your production environment. That's great for security, that's great for compliance, but it's also great for reducing your costs. So how do we do this? How do we limit resource provisioning? The best way to do this on the AWS platform is using the Identity and Access Management service. It's a service that's built into the platform. It's a service that every single one of our services that we bring to market will automatically leverage. And you can think of this as a way to define users or define policies which restrict what certain users can do at a very fine-grained level, even to the point where you could restrict particular users to only deploy certain EC2 instances or leverage certain AWS services like S3 to a very specific region. So for those of you who are very familiar with the platform, and we assume all of you are, you know that all the different regions around the globe have different pricing, depending on the costs we actually incur for supporting that infrastructure in that particular country region. So we know, for example, that the Sydney region and the Japan region, and generally our Asia and South America regions, are a little bit more costly compared to our US region. And so we can put policies in place for IAM to actually restrict my users, or your users, to only deploy into the US regions, or only deploy to a much cheaper region. We can also employ the use of roles, and so roles is a next step in terms of permission and policy allocation. Rather than allocating roles to particular users or individual users, which you can do under an identity and access management system, you're actually allocating roles to other entities, non-human entities typically. So this could be things like the EC2 service. This could be things like the transcoding service. And so you can actually restrict what certain EC2 instances can use in terms of the AWS services. So it's very important that when you are starting out with using the AWS platform, that you have the right access and control permissions in place using the identity and access management system. Okay, next strategy or next recommendation. Obviously, as an existing AWS user, we need to get a good understanding of what is actually deployed on the platform. And not only that, we need to get a good understanding of what costs are associated with what's deployed on the platform. And if you have multiple users, multiple business units, multiple groups that are actually deploying resources under a single AWS account, how do you keep track of which groups and which users are doing what, and which groups and which users are responsible for the costs incurred for those resources? The best way to do this, or to achieve this in AWS, is by employing resource tagging or tags. You can think of tags as a user-defined metadata that you can allocate against nearly every single AWS resource that you can actually deploy. So this could be as something as simple as an EC2 instance, or an S3 bucket, or a relational database service, or it could be even fine-grained down to security groups. Could be down to things like the Elastic MapReduce service, or could be down to things like the EBS volumes. And so essentially this is just a range of key value pairs that you can assign to any one of those resources. So almost all the AWS resources support these resource tagging. And once we've assigned those key value pairs, and by the way, the key values are arbitrary. They can be any key value pair, strings that you will prefer, and that makes it easy to use on the platform. You can then use those tags in one mode where you're actually going to manage those resources. So if you want to get an idea of all the resources, AWS resources associated with a particular environment, such as production versus non-production for your application, or maybe for a certain business unit, or maybe for a certain cost center. So you can use this tagging system to easily identify this and view that information in a nice visual way in the AWS console, or actually use the APIs and integrate third-party tools which will actually give you a running summary of those various resources and how they actually group together using tags. But we're here to talk about cost. How can we use the tags for cost allocation? How can we ensure that we're keeping account of what my legal team is using or incurring when they're using the AWS platform versus maybe my finance team? And so we can use those same key value pair tags for cost allocation. AWS will actually generate these billing reports, detailed billing reports, which can actually group together the resources which have been tagged with similar key value pairs. And then it can actually give you a total amount, a total monthly amount that those resources incurred. So you can be very specific on identifying how much your finance team has used in terms of AWS cost versus your legal team using that cost allocation tagging. We'll always recommend that you actually use tagging as a way to group, manage, and associate costs with your AWS resources. And if we have a look at some of the examples, tagging examples, you can see there's a wide variety. These are just common examples. Like I said, it could be an arbitrary set of key value pairs. But you could use things like cost center as the key value, as the key. And then the value would be maybe a cost center name or a cost center number. And so when you generate your reports, you can easily identify which resources are associated with what cost center. Similarly with things like environment. So you can reference your QA environment versus your production environment versus your test environment versus your UAT environment. And so you again can identify exactly what costs are being incurred by these various environments. And it makes it especially handy when typically your development environments are transient, where they're actually coming and going based on the developer requirements, and we'll cover that in a moment. In addition to using tags, one other option you have is leveraging a fairly new service we have called the AWS Config service. And so when we originally announced this service, its primary purpose or primary objective was to take a snapshot or take a view, a point-in-time view of all of your AWS resources utilized under a particular region. And what would actually happen is if any changes are made to those resources, so maybe as something as simple as starting another EC2 instance, or maybe something as complicated as, or seemingly complicated as changing a security group rule. But any change within that AWS account under that particular region on a particular AWS resource will immediately incur a notification from the AWS Config service, notifying a set of users or administrators that something has changed in the environment. This is a great service to utilize and leverage when you have certain compliance and governance requirements to implement proper change control in your environment. So when you receive a notification, you can quickly identify who has changed a particular resource in that environment. As of reInvent this year, though, we've actually extended on AWS Config with AWS Config rules. And with AWS Config rules, it actually allows the user to put in controls with the AWS Config service. So rather than just sending a simple notification, as was the case with AWS Config when changes are made, a user can actually implement or configure rules to actually take appropriate action if certain rules or thresholds, metrics aren't met. So a good example would be something like a failure to tag a particular instance with a cost center value. And so what AWS Config rules can do is automatically tag that particular instance based on which was the user that actually provisioned that instance in the first place. So hopefully as well, you've got using IAM, separation of duties using separate accounts for your different users across different teams. And using that account information, you can automatically assign a cost center, for example, tag to the resource that was just provisioned without an actual tag in the first place. You could be even more sophisticated. You could do things like integrate the AWS config rules with Lambda. And so most of you will be very aware that the AWS Lambda service is an event-driven service. It's the ability to run a particular function or a piece of code based on events that occur on the AWS platform. So for example, you could write a Lambda function to react to any instance that is actually started or launched by any user on the platform. Or you might want to run an AWS Lambda function which will automatically react to someone uploading or even someone deleting an object from the S3 service. And of course, the AWS config rules and AWS config provide you a nice visualization, a nice dashboard in the AWS console for actually getting a better understanding of exactly what changes are being made to an environment, such as your production environment. So you may be aware that a very popular or common reference customer for us, Netflix, actually make very extensive use of tags. So they've actually gone so far as implementing a particular utility called the Janitor Monkey, which is actually part of the Simian Army toolkit. You may have actually heard of another tool called the Chaos Monkey, which will go and randomly terminate instances based on tags as well to ensure that you have a highly resilient, highly fault-tolerant architecture. Janitor Monkey will actually go through and scan instances, and any instance that doesn't have a particular tag, a particular key value pair, it will either automatically isolate that instance, so remove it from the network, and require the owner of that instance to take appropriate action, or it can actually terminate that instance straight away. And in the case of a large financial services customer of ours, essentially if any instance is started with no tags or no specific tags that are required as a baseline, it will simply terminate that instance. So the users have to ensure that they're tagging the instances appropriately. Okay, moving on to the next recommendation. Obviously, once we've got an understanding of what we've deployed, so we're using things like tags, we need to know, get a better understanding of how we're being billed. What is the actual breakdown of the various AWS services that we're utilizing, and what are the costs involved? As we know, there are actually 60 plus AWS services on offer today across the various regions across the globe. So we need to get an understanding of what costs are incurred at the EC2 level versus what costs are incurred at the S3 level versus what costs are incurred at the workspaces level, and so on and so on. And so the AWS billing console will allow you to do that, as you can see from this slide. So this gives you a very simple, very intuitive interface to indicate your current monthly spend. How much costs in total have you incurred up to this point in time for the month across either all of the AWS services, or you can actually then drill down to very specific services. So you can actually identify what is your EC2 usage. So using this combined with detailed billing reports using tagging, it allows you to get better insights into how you are being billed across the AWS account. Now, of course, as we get to a more advanced level of leveraging the AWS platform, we don't want to actually be logging into a console. That's going to be very reactive. It's going to entail human interaction. We want to have a fully automated system. And so what we can then move to is AWS billing alerts. And if you actually get anything out of this particular session, I hope that you actually go away and set up these billing alerts on your AWS accounts. So billing alerts is a way of getting a projected cost of your AWS utilization based on current usage. And so what you can do is you can set alerts on your total AWS cost or on individual services like EC2 or DynamoDB or even things like data transfer. And you can actually receive a notification once a particular threshold has been met. So for example, you could set up a billing alert to actually send you a notification once a threshold of $1,000 US is projected for the current month. So based on your current utilization and using a projection algorithm, we can actually indicate that you are going to exceed $1,000. And this prevents you from having bill shock at the end of the month. It also allows you to get better insights if somebody was, for example, to spin up a large EC2 cluster and forget to turn it off. It's a very good way to quickly identify that certain resources have been provisioned but haven't been appropriately decommissioned once it's actually not required anymore. So we can actually use billing alerts in a very simple fashion. We can either just set up very simple notification, so simply send an email once a particular threshold has been met, and of course you can have multiple thresholds. So my example of using 1,000 as a threshold for your current spend for a particular AWS account, you might have multiple stages. So you're going to get a notification whether when you hit a $1,000 projected threshold, whether it goes to 1,500, 1,750, 2,000, and so on and so on and so on. So it gives you a better understanding of your projected costs and current utilization of the platform. But of course, we want to get a bit more automated. So you can have advanced alarms with CloudWatch. So not only are you actually going to send a notification to your users that the projected costs for AWS usage is going to meet a particular or exceed a particular threshold, you can actually have an automated workflow to take appropriate action. And the way this works is rather than sending just a notification to an email address, which you can still do with these advanced alarms, you can actually send a notification, an SMS message to a particular endpoint, whether it's something like a HTTP endpoint, whether it's something like a Lambda function, which will automatically take appropriate action. So a good example is maybe for your EC2 billing alert. So once a particular threshold is met with your EC2 utilization for the month, you can actually have a Lambda function which will automatically spin down or power down your existing EC2 instances. And you could actually tie that into something like tagging. So obviously you don't want Lambda to blindly terminate or power off those existing or running EC2 instances. You might tell Lambda to actually look for those instances that are all non-production and have those actually automatically spun down or terminated. So we can have an entire automated workflow using billing alerts and the advanced alarms in CloudWatch. And of course, if we want to get further breakdown, there's some other good visualization tools like the Cost Explorer. It's a very recent tool that we announced in the AWS Management Console. Once again, it not only gives you insights into current utilization like the actual billing console does, but it actually gives you a history. You can compare against previous months what your utilization was for the various services that you're using on the AWS platform. Of course, we don't want to forget about our partners. So whilst things like CloudWatch and the Billing Console and the Cost Explorer does provide you very good insight, you can actually take it one step further and leverage a wide variety of partner tools that will integrate with the various APIs for the services, including things like billing reports, to give you even further insight into how you are using the AWS platform. It gives you some nice visualizations, for example, with your cost allocation tagging. So rather than looking at a raw spreadsheet or a raw CSV file, which will actually contain the billing report information, you can integrate it with one of these partners, which will give you a nice visualization to say what are the costs incurred for certain groups or certain business units across your organization, as long as you are tagging those resources appropriately. So if we have a look at one of our customers that are actually using CloudWatch and CloudWatch alarms to great effect, or to produce great results, Kellogg's. So Kellogg's actually have a very large SAP HANA environment or landscape deployed onto AWS. And what they actually do is integrate that SAP HANA environment, which is obviously running on EC2, together with other AWS services, so things like the Simple Storage service for their backups, things like the Elastic Block Store for their block storage, together with provisioned IOPS, together with the Identity and Access Management System. And so what they do is use CloudWatch, for example, to send notifications when certain thresholds are met for things like the EBS volume. And ensuring that provisioned IOPS, which is one option or one flavor of, so to speak, of the EBS offering, which does incur an increased cost compared to some of the other offerings. They ensure that provisioned IOPS volumes are only being assigned to environments which actually require it. More than likely, you are production environments, where your non-production environments may not require those provisioned IOPS EBS volumes. Okay, moving on to the next strategy. We have, this is probably the crux of, or the most important recommendation, I could say, after you've actually got an understanding of what is happening on the AWS platform. You actually want to identify any idle resources, such as EC2, such as S3, such as RDS, so any one of the 60+ services that you have running, and not only identify those idle resources, but turn them off. And when we say turn them off, we talk about actually spinning down or terminating those instances. Being the good administrators that we are, we want to have automation in place, the ability to automatically or easily provision environments through an automated workflow. So we can actually leverage the AWS APIs rather than the AWS console to automatically turn on and turn off our AWS resources, for example, EC2 instances. Very useful for things like your non-production environment, your developer and test environments. So you can actually expect significant cost savings by spinning down or terminating your non-production environments over the weekend, when more than likely your developers aren't actually working, or maybe outside of business hours. So for example, I could tag an EC2 set of EC2 instances with business hours, yes or no. And so I could then have a scheduler running, for example, a Lambda function, which now has scheduler support, so you can actually set it up very similar to a cron system. Or you might have a third-party tool that will integrate with the APIs, and it will actually scan your entire EC2 usage, and any instances that have the tag business hours equals yes, meaning that they only are needed during business hours, it will automatically power off, or better still, terminate those instances. And we can leverage automation tools like CloudFormation, like OpsWorks, and things like CodeDeploy, as well as a wide variety of third-party tools to automatically provision that environment. So in the morning when your developers come back online at 8 a.m., you can have their development environment quickly provisioned for them. Or even better yet, rather than doing it based on a schedule, doing it based on an event. So as part of your CI/CD pipeline for your developers, which hopefully they'll be using, when they check in code, they'll automatically have a development environment provision for them using CloudFormation as part of that CI/CD workflow. At the end of the day, it's important to remember that instances are disposable. Instances should be transient services, whether they're stateful instances, things like your database, caching systems, storage systems, or even stateless systems, so web servers, application servers, and so on. Your architecture and your environment should be deployed in such a way that if the actual environment was to disappear for some reason, you can easily provision that environment once again. And we can use a wide variety of AWS services to achieve that. If you don't want to go to that extreme, perhaps you're not yet comfortable to going through the automation method, one other option where you don't have to do much is leveraging things like Trusted Advisor. So Trusted Advisor is part of our support offering. It's an API-driven service that's part of the support offering. And what it actually does is it regularly scans your AWS resources and reports based on 4 pillars, as you can see, on cost optimization, on performance, on security, and on fault tolerance. So for fault tolerance, for example, it will report whether you have a highly available architecture for a certain application. Are your EC2 instances spread across multiple availability zones to reduce the impact of an availability zone becoming unavailable? For things like security, it will ensure that the security groups you have assigned to instances aren't allowing everyone on the internet access to your remote admin service ports like SSH or RDP. For things like performance, it will ensure that your EC2 instances are actually performing up to the expectations. Perhaps it will actually even recommend that a EC2 instance you've deployed of a given instance type is actually being underutilized and recommend that you use a different instance type. And of course, the one we want to focus on in terms of cost optimization. So this is actually where we can identify underutilized EC2 instances and a recommendation from Trusted Advisor to either power off the instance, or maybe an instance that is well utilized. It's always actually being used to its full potential, but it might be running 24/7 for a certain reason. So why not use things like reserved instances instead of the current on-demand billing model you might be using for that instance? And I'll talk a little bit more about reserved instances in the upcoming slide. This is all reactive though with Trusted Advisor. It produces a report. Yes, you could potentially write your own scripts and integrate with Trusted Advisor. It is an API delivered service after all, but we've already built it for you. We've actually implemented certain features in CloudWatch to allow you to detect certain underutilized EC2 instances and take appropriate action in the event of that detection. And the appropriate action could actually be the ability to spin down or turn down the EC2 instance, power it off, or actually terminate the instance altogether. So you can actually identify certain metrics of an EC2 instance, whether it's the baseline or default metrics like CPU utilization, network utilization, and disk utilization, or you could actually write your own custom metrics to identify things like the number of processes for your application or the number of network connections coming into an EC2 instance. And because you're reporting these custom metrics to CloudWatch, you can actually set up alarms when certain metrics or certain thresholds rather are met. So for example, if your CloudWatch is reporting that there's no incoming or no active network connections to your EC2 instance, and it might be something like a web server, that's an indication that the web server is underutilized. So we can actually easily spin down or terminate that instance using a CloudWatch alarm and a CloudWatch notification. And once again, there is that option to also integrate into the AWS partner ecosystem. So once again, a wide variety of tools that integrate with APIs like CloudWatch and like SNS that can actually not only give you a good understanding and insight into your current usage, but actually take proactive steps to optimize your utilization to reduce your costs. And if we have a look at some of our customers that are actually taking this approach, where they're actually scheduling the provisioning and the decommissioning of the AWS services like EC2. So we have things like Pfizer, who run very large-scale, high-performance computing environments. So they've actually got a job scheduler, just a third-party job scheduler they've written themselves, or they're using themselves. They will actually provision HPC clusters to start those instances at certain points of the day or certain points of the week. And also, and will also stop those instances or terminate those instances once the actual task has been complete based on time. We've got organizations like Sage, and what Sage do is very similar. They run training classes, so they leverage AWS infrastructure to support those training classes. So they have a scheduler that will automatically terminate that training class's resources at the end of the day when they're actually no longer required. So there's no reason to actually run those training class resources 24/7. Okay, so the next recommendation we have is around designing for elasticity rather than deploy for peak. And if you remember back to the benefits I mentioned of a public cloud platform, this is what applies here, in that we want to actually ensure that our resources are growing and shrinking, not based on projections, not typically based on time of day, but really based on what is currently happening to the system. What is the current demand from your user base on the actual environment? And we can adapt the resources based on that demand. And so you may have heard of features like auto-scaling, and auto-scaling is only one feature that you can use or employ to design for elasticity. And I'll get to auto-scaling in a moment. So the other options we have is simply picking the right instance type. So there are quite a number of different instance types available for any of our EC2-based services, whether it's EC2 itself, whether it's things like the relational database service, whether it's things like Elasticache, whether it's things like EMR for your Hadoop clusters, whether it's things like Redshift, whether it's things like the Elastic, whether it's things like the EMR, like I mentioned. You have the ability to actually chop and change and switch between these instance types. And what that basically means, what an instance type is a representation of the hardware resources that you can actually leverage from CPU, memory, and network. And so once you provision a EC2-based instance, so for example, you provisioned your application server running on a particular EC2 instance, you're actually not restricted or you're not locked into the instance type you chose when you provisioned the instance in the first place. So you actually have the ability to very easily switch between not only specific instance type families, so for example, all the offerings in the M4 family, from M4 large, extra large, 2 extra large, and so on, but across families as well, because each of the families represent a specific ideal use case, as you can see on the right-hand side. So you're actually not locked into a particular instance once it's deployed. You can simply change an attribute on the instance itself. It does require a reboot of the instance, but you can very quickly have a new instance type for your same or existing application. So you have a lot of flexibility when you when you're capable of choosing or changing the instance type. One of the really cool things I like of instance families, though, is the T2 instance family. This is a little bit different in the way it operates compared to other instances. So other instance families, we will always dedicate, or we will always ensure that you have a specific amount of memory, a specific amount of CPU for those instances. The way that T2 differs is that, yes, we still give you the same amount, a specific amount of memory based on the instance type, and we don't overcommit that memory. It is for your exclusive use in that instance. But the CPU itself is capable of bursting. So based on the T2 instance type you deploy, you'll get a baseline amount of CPU for that instance. But for a certain period of time, i.e. when you have CPU credits, you can actually burst or exceed that actual allocation of CPU. So T2 instance types are really handy for a lot of bursty workloads. And bursty workloads are typically your development environments, things like web servers, even things like small databases, where you don't have that consistent performance requirement out of the instance type. And if we have a look at some of our customers which are leveraging T2, we have the Nomura Research Group. And so they're actually leveraging T2 for a whole wide range of application workloads that they're actually running on the AWS platform. So for things like even remote desktops, so they provisioned remote desktops on EC2, but because of the burst requirements or the burst workload of a desktop environment, if you think about it, it's a human being accessing the remote desktop, and it's a human being conducting the different tasks on that desktop. So for example, an office worker or a task worker might be opening applications at certain points, might be using those applications in an unpredictable fashion. T2 instance types are very suited for that type of environment. Or maybe it's their development environment, where they don't need to invest a lot in the very large instance types, because as the nature of a development environment is to test a particular change, to test a particular piece of code, to provide an environment for a developer to test on, and quickly decommission that environment when it's not needed. So T2 very useful for that. Taking one step further, we have a customer called Kaplan. And Kaplan were actually an interesting use case because they implemented a lot of their applications on the AWS platform using EC2 instance types before T2 was actually available. So they moved a large portion of their data center to AWS. And when we actually released the T2 instance type, they identified that a lot of their application workloads are very suited to the T2 instance type. And rather than having to go through and do a fundamental change or a significant change to the environment, Kaplan were able to actually change the EC2 instance family, EC2 instance type they were using to T2 by just a series of API calls. And immediately when they were able to change to the T2 instance type, they were able to achieve significant cost savings and cost reductions by moving to that instance family. And in actual fact, now going forward, Kaplan actually used T2 as the go-to EC2 instance type, aside from special use cases where they might need the larger instance family. Okay, moving on to autoscaling. Just quickly cover autoscaling. I'm sure many of you are familiar with what autoscaling does. So autoscaling is built into the EC2 service. So most of the services that are based on EC2, like your Hadoop clusters, like or EMR, and like your EC2 service, allows you to actually put in rules or put in policies that will automatically grow, in other words, launch new EC2 instances, or shrink, in other words, remove EC2 instances to a given tier. And that policy could be based on two things. The first one is based on the demand, or based on what CloudWatch is reporting in terms of the utilization of the entire EC2 autoscaling group or tier. So once a particular threshold is met, the policy invoked by autoscaling could automatically add instances to the group. Or maybe the instances are underutilized, for example, CPU. And so the autoscaling policy could automatically remove instances from that tier. Now, autoscaling has been around for quite some time, but it's only recently we've actually seen some really cool features or iterations applied to the autoscaling feature. And so this includes the ability, for example, to have more control over what EC2 instances are actually decommissioned or terminated when autoscaling invokes a policy to start removing instances because demand on the system has subsided. In fact, as early as today, we actually released a feature which allows you to identify certain instances in the group that can never be terminated. Because normally when autoscaling was to terminate an instance because it needs to scale down, it will go through a particular algorithm or policy to terminate, generally terminating the oldest running or oldest living instance. But in your autoscaling group, for some reason, you might have a particular master instance or master node and you never want to terminate that instance. So you can identify that master node as immutable, or it can't be terminated by autoscaling, and autoscaling will always terminate instances around that master when it was to invoke a scale down. The other policy we can invoke with autoscaling is a schedule policy. So maybe your workload is more predictable. So maybe during business hours you need more capacity for your particular application. So with autoscaling, I can implement a scheduler to indicate what time of day, day of week, day of month I actually want to increase or decrease my autoscaling group. Autoscaling also provides another feature, not so much associated with cost savings, but really associated with resiliency. And it's the ability to actually actively monitor all the EC2 instances in the group and automatically delete or terminate those instances which have been identified as in a failure mode or an unhealthy state. So maybe the EC2 instance application it's hosting has failed, maybe the kernel has actually panicked. And so rather than a human being having to re-provision a new instance in its place, autoscaling will take care of that for you, all automatic and all hidden from the administrator team, other than the notifications you can configure to actually indicate that autoscaling has caused an event. One other really good thing I like about the EC2 instance types is, as we know, we're not locked into specific instance types, but it also allows us to adjust for utilization and granularity. So if you think about it, we can actually provision a larger number of smaller instances to achieve the same results as a less number of larger instances. And what we actually find is by taking this approach, we can incur a lot of cost savings. And so let me give you an example. So here we have a particular application workload over a given month, and the green blocks represent the number of EC2 larger instances. So as you can see, during the middle of the month, I've actually scaled my system, maybe using autoscaling, to a larger number of larger instances. What I can actually do is, rather than deploying these instances, which will incur this amount of costs, so 29 M4 larges at a price point of 2,600 plus over the given month, I can actually achieve the same capacity using a larger number of smaller instances. So instead, I'm going to deploy 59 or up to 59 T2 medium instances across the given month. It provides the same capacity and capability, but you can see there's a little bit of a cost saving there. So it's very important to always evaluate and get an understanding of how your instances are being utilized. We could even go one step further, and we could use things like the EC2 container service, which is actually containers on an EC2 instance, to increase the density, increase the utilization of my EC2 instances for individual or separate simple applications. If we have a look at some of the case studies around utilization of the platform, of course we have Netflix, again, very popular reference case. I won't go into that in too much detail, other than to say, if you think about Netflix's offering or business model, most of their traffic, most of their usage with its customers is on a Sunday evening. In fact, a large majority of internet traffic is made up of Netflix content on a Sunday night. So they have a very spiky but predictable workload environment. And so they can use auto-scaling to actually scale to maximum capacity or scale to the required capacity to meet the customer demand on a Sunday night. Or if we have an organization like Ticketly, which provides online ticket sales, so when they run campaigns and when they run events where they're selling tickets for those particular events, they're able to easily scale up their infrastructure using services like auto-scaling based not only on customer demand, but also when they actually launch those particular campaigns and events. Okay, so let's move a little bit onto the commercial model, more the billing side of things. There's actually multiple billing options you can apply to most of your AWS resources. So typically when you're using the platform, you're using EC2 instances and also those services which leverage EC2 technology like RDS, like Elasticache, like EMR, for example. Typically using on-demand instances. And what that basically means is you're essentially paying a specific price point per hour for that instance as advertised on our website. This is typically the highest cost you can pay for a particular instance in that particular region. And it is that higher cost because it allows you to provision an instance as whenever you like it or whenever you need it. And so what we can do instead is actually use a reserved instance billing model. And this is purely a billing model. It doesn't change the way that your instances operate and function. But what our billing system will do is once you pay an upfront fee for specific instance types in a specific availability zone in a specific region, we will automatically apply cost savings or a reduced hourly price for that instance. And our billing system will always try to charge you the least amount possible. So once you purchase reserved instance slots or reserved instances, you have the ability, or our billing system then has the ability to scan the entire AWS environment where you have instances deployed and actually consume those reserved instances first before incurring the on-demand pricing for the rest of the instances you have. And one of the additional benefits of reserved instances is because you're providing that upfront commitment or the upfront fee for using reserved instances to get that reduced hourly cost, we can also provide you with capacity reservation. So we have the ability to have more insight and more understanding of exactly the capacity requirements of your application. And so therefore we can allow you to have access to that capacity whenever you actually need it. So we'll always have a certain amount of capacity for our EC2 infrastructure reserved for your use. So you won't actually be competing against other AWS users on the multi-tenant platform because you have that capacity reserved for you straight away. Of course, we also have the spot instances. Spot instances is one of the really cool billing models I really like because it provides the ability for customers to actually bid or propose a per hour price they're prepared to pay for any of the excess capacity we have in our availability zones and in our regions. So if you think about it, when we provision EC2 infrastructure, we need to ensure we have enough reserved capacity, we have enough excess capacity to support users who are provisioning instances on demand. And so rather than actually making that reserved or excess capacity go to waste, we actually offer the reserved capacity or the excess capacity in the form of spot instances. And it's all about a supply and demand market or supply and demand environment. And so what will actually happen is every few minutes, each of the individual instance types will have a specific spot price based on the current demand of that particular instance in the spot instance environment. And when any users have bid for a particular instance at a specific price point for their spot instance, we will automatically launch the instance for that user once the bid price goes below once the spot price goes below the bid price that that user has put forward. The trade-off here is obviously interruption, where Amazon can actually remove that capacity, remove those instances once the spot price goes back above the bid price. So spot instances aren't recommended for stateful environments where you may need that particular instance to be persistent rather than transient. Spot instances are recommended for environments where the outcome is not time sensitive, but it would be beneficial if you can add more capacity, but at a price point you're prepared to pay rather than the normal on-demand and reserved instance pricing. So spot pricing or spot instances are very useful for things like Hadoop environments or EMR environments. And of course, you can have a combination of all three. So the ability to actually combine your on-demand plus your reserved instances and your spot instances. And the one takeaway from this is to keep in mind that the actual instance itself doesn't change in the way it operates, doesn't change in the way of the resources you have access to when you're using a combination of these three. So a reserved instance will operate in the same way as an on-demand instance together, and similarly with a spot instance. Just looking at some of the case studies of customers that are using reserved instances and spot instances. Just wanted to highlight maybe the bottom one there, the Novartis customer. So they actually run a wide or a large computational cluster, and by leveraging on-demand instances or reserved instances, it really actually put the cost way ahead of what Novartis were prepared to pay, even using the AWS platform. The cost was actually simply too much using the on-demand or the reserved instance pricing model. And so what Novartis saw is they could actually use spot instances to provision a very large-scale infrastructure that would normally cost them millions of dollars on-premise for a very small fraction of the cost. You can see there just over $4,000 to run a spot instance cluster to give them great results from a very large cluster environment. All right, moving on to the storage classes. So one other option we have, other than the EC2 instances, is we can leverage the right storage classes. So as we know, for the S3 service, there are actually multiple storage class offerings. So in addition to the standard offering, which is the highest price point per gigabyte, and provides the best reliability as well as the best durability, we also have the reduced redundancy storage, which reduces the durability, so the data is not stored across many facilities, and therefore you have a reduction in the per gigabyte price point for the storage. We've also introduced the infrequent access storage class recently. It's really suited for those environments or that data, which, as the name suggests, is going to be stored durably, but required infrequently, so maybe your backups. And then for things like archiving, where you're generally going to be storing content and very rarely accessing the environment. So for example, you're doing a read once, read never type of deployment, maybe for compliance and governance reasons, you need to archive or retain data for a certain period of time or a certain number of years. You can leverage the Glacier storage class. And so all of these are actually built into the S3 service, where through an API call, you can actually indicate exactly what storage class you want to use, and this is all done at the object level. So you could have multiple objects in your bucket using different storage classes. Not only can you use the API calls, but you can also use S3 lifecycle rules to achieve similar results. So you can place policies on buckets to actually automatically cycle through the different storage classes to make more efficient use of the S3 service. In addition to that, obviously, we've got those 60+ services I mentioned, and I've really been focused on EC2 and S3. But don't forget, we've got a lot of other managed services that we can take advantage of that really allows us to offload a lot of the requirements we've placed on EC2, for example, to these managed services. Not only do you get the benefit of being able to not have to manage from the operating system up, because we take care of that with the managed service, but typically you get a reduced cost, because running an EC2 instance per hour would typically cost more than actually running the managed service. And a good example is where we want to offload serving of content from our EC2 instances and S3 to CloudFront. So CloudFront is a globally distributed service It's our CDN that allows us to bring a lot of our static content a lot closer to our globally set of distributed users. And as you can see from the slide there, we can actually offload a lot of that from the EC2 instance itself. We can reduce the footprint required for the EC2 instance, and we can then get significant cost savings by offloading a lot of that serving from CloudFront. We could do some similar things with things like caching with our service like Elasticache. So rather than having a large database like a relational database service, which is performing a lot of read transactions, which is typically what's happening in an OLTP environment, we can actually use things like Elasticache to offload a lot of those requests from the database server and therefore reduce the actual physical footprint or instance type of that RDS server and therefore incur some great cost savings. And then just to conclude, I'm just winding up some time here. We've got customers that are actually leveraging things like CloudFront. As you can see, I won't go into too much detail. Not only does it have the benefits of serving their content a lot quicker around the globe, but they can actually achieve a lot of cost savings by offloading a lot of the capacity requirements onto the CloudFront service itself. And finally, just to conclude, the other option we're seeing customers is going serverless. So basically being able to implement architectures which absolutely don't require EC2 at all. If you have a look at your monthly bill, you'll probably notice that a large portion of the costs incurred by the EC2 compute. So if we have a way of actually eliminating or at least reducing the EC2 utilization, we immediately will see some great cost savings. And in this example here, we actually have a gaming, we've got a mobile game that's actually served by S3 directly using JavaScript. So it's actually client-side executable code. So the client or the mobile client will access that JavaScript from S3 directly. It will then integrate and work with things like our Cognito for authentication, so you don't need to run authentication services on EC2 anymore. It will then invoke functions in Lambda, so we don't need to be running an application on EC2 anymore, and Lambda will actually execute the function only when requested. And then Lambda in turn will use persistent storage services like DynamoDB rather than maybe your EC2 instances you traditionally use as well as RDS. So all in all, we can actually achieve significant cost savings by going serverless. In fact, here's a great example of where we can offload a lot of our EC2 usage for our web application into a Lambda function. And because Lambda is charged by execution time rather than by deployment, even for very large-scale usage of requests to the Lambda, so in this case 16,000 requests per day to the Lambda environment, we're able to actually reduce our costs significantly compared to EC2. So just to conclude now, remember to iterate when you are working with the AWS platform. You'll notice that we're constantly bringing out new services, new features. I might have actually introduced some new services and features there. So we want to ensure that we're always evaluating those new services so we can offload a lot of the work, especially on things like EC2 and RDS, which is typically incurring most of your costs. A really good example there is the AWS WAF service we recently announced. So providing web application firewall capabilities through the CloudFront service rather than having to run your own on an EC2 instance, and therefore significantly reducing your overhead in terms of cost, time, and resources to manage a WAF implementation. And then finally, we want to use consolidated billing. So the ability to link AWS accounts together so we can actually reduce our overall spend. And we do this by leveraging multiple accounts, aggregating the usage, and then achieving volume discounts on storage and compute with things like reserved instances. Now with that, I'd like to thank you very much for your time. In terms of the next steps we would recommend, there are a wide variety of free and paid for online labs that you can use and you can do through the online labs and training. We've also got instructor-led classes that can allow you to start your journey and get you on the path to become certified professionals and certified associates on the AWS platform. Any further questions? Unfortunately, I have gone over time, so I won't have time to address any questions, but any questions that you might have that haven't been answered by our SA team during this session can also be sent to the AWS APAC marketing email, as you can see. Thank you very much once again for your time. Apologies for running a few minutes over, but I hope you enjoyed this session and continue to do so with the rest of the AWS APAC webinar this week.